Just need to erase all the things on it. There we go. Yeah. So I'm going to give you a few minutes to work on this yourself. Let's do 4 minutes. Try to do as much as you can. Again, I don't expect you to be able to do every single part of the problem, but at least try to, get all the interpretations done, right? Gather all your information, get all your equations, and try to at least get that down. Okay. Let's make this a little bit smaller. We'll zoom out so we can see everything. Okay, there we go. By the way, we did get a lot of 127 out of 177 responses. That's good. Should we do something for the final where if a class gets above 85% response rate on the end of semester surveys, that class gets like a 1 point extra credit for the whole course? Should we do something like that? And so then some sections will get the extra credit, some won't. And then when I get complaints and grade appeals at the end, how come my class got the 1 point and yours didn't? It's not fair. Do you think that's good? That's a good idea. Yeah, your dreams, please. You would love to see me get those emails. Okay. So what do? What variables did we introduce? So we have 15 minutes to solve this problem. I need some variables. I need some whatever. I'm not solving this problem for you. dy dt equals 4. I have no idea what y is, Jacqueline. What's y? Give me an English description of y. You can't use your microphone. You got to type it. You have to type it. You can type it if you want.
Lantern, I think. I don't know.
Okay. You don't. You're just guessing?
Yeah.
Why are you just guessing?
Height of the lantern, but I don't know.
Why are you saying, but I don't know? It seems like you're pretty confident that dy dt equals 4.
Yeah, okay, I'm confident.
Okay. Okay, so I'm going to call it h because that's what's in my notes, not y. So I'm going to call this the height of the lantern above the point P, obviously. Come on, why is this? There we go. No. You know, sometimes. Okay, that's close enough. All right, so that's 15, right? Right, Jacqueline? That height is 15?
Oh, yeah, sorry, yeah.
It is?
Awesome.
Mohammed, what do you think?
The height is 15.
The height is 15? Thomas, what do you think? I haven't heard from you today, Thomas. It's a changing variable, right? So in other words, Thomas is saying it's not 15, right? I cannot label this as 15, right? It has to be labeled as a variable. It has to be labeled as H or Y, whatever your favorite letter is, right? If you label it as 15, you're telling me that that is always 15. And is that length always 15? No, right? Do not label things as constants if they're not constants. Okay, so given that H is this thing, the height of the lantern above the ground, and now we also have some given information. Now, Jacqueline claimed, what did she say? dy dt equals 4. Well, in my language, that would be dh dt equals 4. Now, do we agree with Jacqueline? Justin, I see you shaking your head.
Is it -4 since the height is decreasing?
Okay, good. So it's actually -4, right? Since the lantern is falling, that means that length h is actually decreasing. So I actually need a negative rate of change here. Good. So make sure you actually have that negative. Okay, what other variables do we need? Obviously, there's at least one other variable. We can't just have one variable. What other variables do we have in this problem? ds dt. So what is s? S equals shadow. I think you mean S equals length of the shadow, right? Not just shadow. Now, it's very important that we understand what is the length of the shadow. Can you describe that to me? Now, how do we usually describe length? So maybe I'll make this easier on you. How do we describe length? So if I wanted to describe this length h, I would say it is the length from the lantern to point P, right? So how would you describe the length of the shadow? So Kevin says the dotted line behind the person. So this length, Kevin? So that's not quite what the length of the shadow is. It's not the diagonal. The length of the shadow is actually this length. The length from the person's feet to where the light hits the ground. Yeah, it's the length on the ground. So Kevin did correct himself. So that is the length of the shadow. So it looked like some people said, called it S. My notes call it X, so I'm gonna call it X. Now Thomas said X plus 8 would be the total length. Yeah, so I wanna make clear that the whole entire thing is not the shadow. There are actually 3 horizontal lengths in this problem. There's this length from the man's feet or the person's feet to the point P. Now in this problem, what is that length from the person to P? That is a constant. That is always equal to 8. And I want to be clear that let's say that that wasn't a constant. Let's say that that was actually y. Like let's say the person is also moving away or towards the lantern. It actually turns out that x, y, and x plus y all actually change at different rates. So they are bona fide like different lengths. So x would be the length of the shadow, y is the distance from the person to the lamp post or whatever, and x plus y is just the total length. In other words, x plus y is actually the length of the tip of the shadow to the lantern. And actually all 3 of those quantities change at different rates. You may not believe it, but they do. So now in this case, I mentioned that because there is a problem like that in the homework, but that is 8. Are there any other variables or constants of this problem that we need to make sure we write down? The height of the person is 5 feet, right? So this length right here is 5. Oof. Okay, now what other given information do we have? Is there any other information we have? dHdt equals -4. Typically, we also write down what are we solving for. So can we at least say maybe what we're solving for at what specific time? That's usually also what we write down here. What are we solving for at what time? So it's something when x equals 15. It's not quite when x equals 15, but we all solving for dx dt, right? We're solving for, it says, at what rate is the length of the person's shadow changing? So it's directly asking us for dx dt, right? How fast is the length of the shadow changing? So dx dt equals question mark when what? When what is true? Someone say when h is 15, right? When the lantern is 15 feet above the ground. Okay. So that is all the information that we can extract from this problem, right? Let's just do a double check. 5 foot tall person. Good. The 5 is already there. Stand still 8 feet from the point P. The 8 has already been in the diagram, which is directly below the lantern. Fine. At the moment when the lantern is 15 feet, so when h equals 15, that's taken care of. The lantern is falling at a rate of 4 feet per second. That's the dHdt equals -4. At what rate is the length of the person's shadow changing? That's the dx dt equals question mark. So everything we have gotten already, so we no longer need this English description of the problem. We can kind of get rid of it. So let's zoom in and scroll down. Now, obviously, we're still missing a little piece. So we are still missing a piece because we have nothing to differentiate yet, right? We need an equation that relates our variables. Now, our only variables are x and h. How do I relate these two? What geometry am I going to use to write down an equation that relates x and h? So to find an equation for x and h, we use proportions. To make a proportion? Yes, we do. Does anyone remember what this is called? Similar triangles, yeah. So we use the principle, we use similar triangles. I'll just say that. And like a few people have said, this really comes down to a proportion, right? If I have 2 triangles that share an angle, right? These two triangles share an angle. So if you have 2 triangles that share an angle, corresponding sides are in the same proportion, right? Just to remind you of that. So in this case, we can say what? What I usually like to do when I do set up, what's it called? When I set up similar triangles, I like to write the thing down and the equation down kind of in English to remind myself like where to put everything. So I'm going to say like this. I'm going to write down large length. In other words, the length of the large triangle divided by the height of the large triangle, right? Large length over large height should equal the small length over the small height. Or you can have it the other way around. You can do small height over large height, small length over large length, right? You can either do small over large equals small over large, or large over large equals small over small, right? It doesn't matter, but all the proportions are the same. Okay, so what is the large length? The large length is x plus 8. Actually, let me just write that in the next line. The large length is x plus 8. That's the length of the entire triangle. The large height is h. The small length is x. And the small height is 5. So just to be clear what we're doing here. So the small triangle I'll highlight in orange, and the large triangle I'll highlight in pink. So the large triangle is this triangle. Oops. And the small triangle is this triangle. So just so it's very clear. Okay, so I'm just going to rearrange this equation a little bit. Remember, I do need to take a derivative of this, right? I need to do, the person is 5 feet tall. Oh, how do I get 5? Yeah, the 5 is coming from the person is 5 feet tall. Rearranging the equation gives, the reason I'm going to rearrange this is because, remember, the next step would be to differentiate this equation, but I don't really want to use quotient rule and all that right here. So I'm just going to kind of rearrange this. I don't have to. And if you do a little bit of algebra, so for instance, if you were to multiply both sides by h and divide both sides by x, you would get the following. You get h over 5 equals 1 plus 8 over x. And then you can even multiply by 5 if you want. So I'm just going to solve for h essentially. So I do get that h is equal to 5 plus 40 over x. That's my equation. Yeah, so essentially I just cross multiply and solve for h. That's all.
Wouldn't it be like 40 over 5x?
I don't think so. So let's
Oh.
see, multiplying, we get 5x plus 40 equals xh, and then dividing by the x gives me 5 plus 40 over x. Yeah, so it's correct. Remember the 15, why 15 has nothing to do with the problem yet, right? Why does 15? So there's a question, shouldn't it be x plus 8 over 15? In other words, the question is, why is this h not equal to 15? We've already addressed this, right? We have to have an equation that holds for all time, right? Exactly. H is a changing variable. Is this vertical height always equal to 15? No, it's always equal to h, right? But it's not always equal to 15. So we have to make sure that we have x plus 8 over h, right? If you had 15 here, what would this equation be saying? This equation would just be saying x equals some number, and x is not changing over time. But we know x is changing over time, right? So again, that's the mistake of putting in 15. That's substituting in too early, right? You're welcome. Okay, what do we do now? So we have this equation. What do we do now? So I'm going to call that equation 1. How do we continue to solve the problem? So in the last 2 minutes, I'll kind of just do everything, right? We differentiate, we substitute, we solve. Right? I mean, once you get to this point, it shouldn't be too difficult, or at least it should be the easier part of the problem, right? So let's differentiate. So I get here dh dt equals 0 minus 40 over x squared dx dt. Okay, now substitute. I think the only thing we had was dHdt is -4. Right. And h equals 15. All right, so the first equation, 1 star. I have 1 star and 2 star. The first equation gives me h equals, 15. 15 equals 5 plus 40 over x. And the second equation gives me -4 equals -40 over x squared dx dt. So now we do algebra. So from 1 star, we get x equals 4, right? 40 over 4 is 10, plus 5 is 15, good. So from 1 star, we get 4. Then from 2 star, we get -4 equals -40 over 16 dx dt, and solving for dx dt gives us whatever it is. What was it? 8 over 5 feet per second. And that does put us right at time. And I want to emphasize here, notice that dx dt came out to be positive, right? That makes sense. If the lantern is falling down, right, the angle that the lantern kind of makes with the man is now kind of a smaller angle, right? So what happens as this lantern falls down, right? Now the lantern is over here. What's going to happen? I have an angle like that. So the length of the shadow actually should be increasing. That makes sense.